To determine whether this is a function, the quickest way is the vertical line test. So this one is not a function, and this one is a function. A side note, this one right here is not one-to-one. Alright, so now we're going to determine whether this is odd, even, or neither. This one is neither. It has some symmetry, but it's not symmetric to the origin, like this part doesn't come down here. This one is odd, or it appears to be odd. We're not sure, but it appears to be odd. There would be a proof that we would have to do to it, but this would be part of the test where you just choose what it appears to be and you would get full credit. This appears to be even. We're going to be doing a little bit more of this in the next class. So the domain, you move along from left to right to see what x's are included. And so my domain is from -1 to 3. Right, so domain is -1 to 3. You've done this before. Range is from 0 to 4. Again, you had that on the first test. So range, nobody asked the range, so I don't have to do that. But the range would be 0 to 4. All right, approximate the zeros, or x-intercepts would be -1 and 2. And over what intervals is f increasing, so it would be on this interval and this interval is where f is increasing. And you say when it's increasing. So during this time, from -1 to 0, so you say it along the x-axis from -1 to 0, your graph would be increasing. You don't even care where it goes. So like if I draw this graph, it's increasing, decreasing, increasing. So it's increasing from here to here, and decreasing from here to here. It's decreasing, and then it's increasing. And so you would name it along the x-axis. So this one's increasing from -1 to 0. And you can put that in parentheses, not brackets. So it's not a point, but it's -1 to 0. And then it increases again during this time frame from 2 to 3. If you do the Delta math on this, they do a good job of showing this to you. It's decreasing during this time, so you always name it as a window of time that it's decreasing. And so it's decreasing from 1 to 2. So this graph is decreasing during the time, 0 to 2, in parentheses. Increasing, decreasing, we put in parentheses. All right, on this one, if it's an even function, then what would happen is -1 would be 3, and the opposite would be 3. If it's even, -2,5 and +2,5. Complete the graph if it's an odd function. So I'm going to take this point that looks like about 1, -1/4, and put it at -1, +1/4, complete opposites. Somewhere over there, so it's going to go like this. And out to 2, 0, so that's going to be -2, 0. So that point's about right there. So it's going to go like this, and then it's going to stretch and go like around 3, 1.5, so that's going to be -3, -1.5. And then this is like 5, 3.5, so this is -5, -3.5 to help you draw your picture. So it goes like this. Alright, so to find the inverse, the first thing you're going to do is write it as y equals 2x plus 3. And then you're going to switch x and y. So x is 2y plus 3. And then you're going to solve for y. So I'm going to subtract 3. So I get x minus 3 equals 2y. And then I'm going to divide by 2. And so I get y is equal to x minus 3 over 2. And so my inverse is x minus 3 over 2. Should be the complete opposite operations of multiplication and addition. we've got subtraction and division. So now we're going to graph both of these. And so I'm going to graph this one first, the one without the fraction. All right, so I'm going to put in 1, and I get 5. I'll put in 0, and I get 3. And I guess I'll put in -1, and I get 1. You can take your time and do that with Scratch. Now these should switch, so the 0.51 should be here, and you can verify that that would happen. 5 minus 3 is 2, and 2 over 2 is 1. It's hard to read these points anymore. That was 1, 5. This one's 0, 3. So this one should be 3, 0, and you can verify that it would work in here. And then if I put in 1, I will indeed get -1. My x's and y's will switch. Now I'm going to graph them. So I'm going to graph this one first. I have the 0.1, 5, 0, 3, and -1, 1. I'm just draw as straight a line as I can there. Alright, I'm going to graph 5, 1, and 3, 0, and 1, -1. And draw as straight as line as I can there. Saw a few on your papers that you had done a good job on this. And if they are inverses, they flip over the line y equals x, which will go right through the origin. So that should make you feel good about your answer. All right, now I guess on this worksheet I didn't ask you to prove that they were inverses. But if we were going to prove they were inverses, let's go over here. Say there was a C part, which there will be on the test, to prove they're inverses. All right, so you take the first one. So take f of x. You'll write this down for me. You're going to do this, and you should get x. And then you're going to do this, and you should get x. What that means is you take the original 2x plus 3, and you put the entire inverse into it, x minus 3 over 2. And then order of operation, you cancel your 2's, and then your 3's cancel, and you get x. That proves that they're inverses. Now you do it the other way around. You take the inverse, x minus 3 over 2, and then you put the original into it, 2x plus 3. The 3's cancel, and you get 2x over 2, and so you get x. And when you get this, that proves that's what happens with inverses. And the point will be made down here. So for each of the following pairs of functions, state whether they are inverses by finding f of g of x and g of f of x. If these are inverses, then when I take f of g of x and g of f of x, I should get x. In other words, putting one inside the other. So f of g of x. I'm going to go find f, x plus 1 over 2. I'm going to put g into it, 2x minus 1. Instead of a number, I'm putting a whole equation into it. On the top, the 1's cancel, and I get 2x over 2, which is x. Oh, so it has symptoms of an inverse. Now let's try g of f of x. So I take g, which is 2x minus 1, and I put the whole equation into it, x plus 1 over 2. This cancels, and you get x plus 1 minus 1. You get x. When that happens, that can only happen with inverses. So you would show your work, your two proofs, and the answer to that is yes. All right, and number 8, I think I left off part of number 7. So you should try the B part yourself, because I can find it. I don't think I have a copy of it. Let me see. Yeah, so I don't have a copy of the B part, but try the B part on your own, and if I remember correctly, those will not give you x, and so they're not inverses. All right, so now we're going to make a table for the inverse. And so our x's are negative 10, negative 4, 2, 3, and 5. And our y's will become negative 2, negative 1, 0, 1, and 2. And so everything should happen if you take f of the inverse of x, you should get x, and the inverse of f of x, you should get x. And so you could check it with some numbers like f of the inverse of negative 10. You should come out with negative 10. All right, so the inverse of negative 10 is negative 2, and f of negative 2 is negative 10. It goes full circle. But that's what we're doing when we say this. All right, determine whether an inverse function exists. All right, so what do we mean by that? First of all, let's make sure what we have is a function. So this is an original graph, and the question is, when we invert all the points, will it function? So if we took all of these points and inverted them, they would flip over the line y equals x, which they're not asking you to do right now, but that's what would happen. And we want to know, once we invert it, would it still be a function? So you do the vertical line and the horizontal line test. So on this one, we would have an inverse that functions. On this one, it functions, but it's certainly not one-to-one if I did a horizontal line test. So this one would have an inverse, but it would not have an inverse function. Right, and then proving even, odd, and neither. So to prove even, odd, and neither, I give you f of x, and then you find f of negative x. So what you're doing is I give you a direction, you go the other direction and see if you get the exact same result every single time. You might be going this way, and then you need to go this way. And if your graph is even, I think you know what I'm trying to do there. I was trying to make them even. My pen's kind of messing up. But anyway, if it's truly even, if you go this way or this way, you get the same x every single time. So I'm going to go opposite x's. So I have 2, put in negative x to the 5th minus 1. That's 2. A negative to the 5th power is negative x to the 5th minus 1. That gives me negative 2x to the 5th minus 1. So you check and see if these two are exactly equal. These are not equal, and so it's not even, so we go in and check for odd. To check for odd, what can be confusing about it at first is then you've got to find, this kind of little, you've got to find negative f of x. That's what it says right there. All right, so to find negative f of x, you could keep going back to this, and you make the whole thing negative. So that would be negative 2x to the 5th minus a negative 1 would be plus 1. And so then you check these two. So this one is not even, it's not odd, so this one would be neither. So you do this every time. I give you a function, you find f of negative x and negative f of x from this function. So you go back to this function and find f of negative x. If those two are equal, it's even. Then you go back to this function and you make it all negative or change all the signs. And if these two are equal, it's odd. All right, so I'm going to use this function to do both parts. And so I'm going to go 2 times blank squared plus 5, and I'm going to fill in negative x. A negative squared is a positive. And I notice these two are exactly the same. So this function is definitely even, and it can't be both odd and even. But if I were to check negative g of x, I would go back here and put negative 2x squared minus 5. And so once again, you are given an f or a g of x. You find f of negative x and negative f of x using this. And then you compare these two and these two for even and odd. All right, on this one, I'm going to say 2 times negative x cubed minus negative x. That gives me a negative cubed is negative 2x cubed, and minus a negative x is plus x. Check these. Those are not exactly the same, so it's not even. Alright, so now I'm going to go find negative h of x and check these two. So if I make this negative, I get negative 2x cubed, and a negative of a minus is positive. And I notice that these last two are exactly the same. And so that means it's odd. And then if you have a fraction, well, first of all, to do m of negative x, you have negative x squared plus 3 over x. I'm going to put in negative x for both of those. Take your time. A negative x squared is a positive over negative x. These two are not quite the same, so it's not even. So now let me check for odd. So I'm going back up here, and I'm going to make m of x negative. Alright, now be really careful with a fraction. If you make it negative, either put the negative all the way through the top or all the way through the bottom. So decide if you're going to put the negative in the top or if you're going to put the negative in the bottom. The reason for that is, say if I have 5 over 6, if you put a negative in the top and a negative in the bottom, you haven't made anything negative. A negative over negative is a positive. So to actually take the opposite of this, you've either got to say negative 5 over 6 or 5 over negative 6. So if you have a fraction, just choose which place you're going to put it. I like this one because I can see they're the same, and so this graph is odd. And so that's what we talked about, one of the most things that we talked about in class. So just to recap, I'll give you a function. You find f of negative x, and then go back and take the negative of f of x. If these two are equal, it's even. If these two are equal, it's odd.